At the top of page 3 for 1.7, we've been multiplying and dividing positive and negative numbers here. It is time to bring in the algebra, bring in the variables. And we're going to start with number 92 here as an example. You've got negative 4 outside the parentheses, negative 3x plus 2. So what's different about this is we've got a variable and we also have things going on inside the parentheses. Let's look again at those instructions. Simplify each algebraic expression. Expression means there's no equal sign. We're not trying to solve here. We are just going to make this simpler. And that means two things for us. When you see simplify, I want you to automatically start thinking about two things to do. The first is to remove all parentheses possible. And that may mean just notice that it's highlighting a negative number for you, kind of protecting it so it stands out. Could be that you need to multiply. It's just a number sitting inside of a parenthesis waiting to be multiplied by the number outside of it. But it could also be something like this situation where you may have to distribute. Let's spell that very good. Or I didn't leave myself enough room, sorry. Distribute. Okay, may have to distribute there. The second thing that we're doing when they ask us to simplify, after we've removed all the parentheses, possibly using distribution to do so, is to combine like terms. Exactly matching variables, and the variables have to have exactly matching exponents, if any. And of course we can combine constants too. And we'll talk later in the term about why constants are like terms. Because the definition of like term is an exactly matching variable. Very interesting how it all comes together. It all makes sense as you continue to add information in. So looking at the negative 4 and distributing here, the reason why we can distribute is because you've got a negative 4 on the outside of parentheses. The parentheses, the two terms inside, are being added together, and you can distribute across addition. You do not want to distribute when all that's happening inside is multiplication or division. You only distribute when it's addition. Now, it could be subtraction too. In this case, you would see us practice changing that subtraction to adding the opposite so we don't lose any negative signs along the way. You don't have to do it that way. You want to find a way that makes the most sense to you. The results should all be the same, but you want to find a way that makes sense to you and you can confidently get the right answer every time. Okay? Because they quickly get more involved, as you'll see in the next example that we're going to do together. So I will show every single step. You may not need to show as much, but again, every step you show now builds those strengths and skills for when the problems get harder. So you decide what's working best for you. What this looks like is negative 4 being distributed across the two pieces of multiplication here. So the adding sign came down, the 4 is being multiplied to both, and I've got it being multiplied to the negative 3x as well as to the 2. Notice the sign came with the item here. The addition came straight down in between, but the sign in front of each term went. This is a positive 2 that's being multiplied by. This is a negative 3x that's being multiplied by. And so now we have a negative times a negative. Again, if you need to think of it in terms of reassociating the 4 times the negative 3, that gives you a negative times a negative, that gives you a positive 12 times x. Or if you can start to be real comfortable with just seeing negative 4 times the quantity negative 3x, it's not addition, this is not distributed, it's simply by association we multiply that negative 3 and negative 4 together. And negative times negative gives us a positive 12. And then we've got negative 4 times a positive 2, so that's going to become a negative 8. We've gotten rid of the parentheses. This is one where we do not have any like terms to combine. So we are done with simplifying this expression. And you can write that as 12x plus a negative 8, or you could write that as 12x minus 8. That means the same thing. Or you could write this as negative 8 plus 12x, where you keep the sign with that 8. Keep the negative sign with the 8. Excuse me, switch it around the addition sign. All three of these would be acceptable answers. This is kind of where you'll see things land in terms of how things are going to look towards the end of the term. It doesn't make it more right, it just is in a format that's going to help us make better sense of linear equations and their graphs. Let's look at 96 together. I picked this one out as an example to show in the video because I think it hits several of the highlights that tend to trip people up. So watch through this one, make sure you fully understand it, and come with questions to class. My first suggestion is that you change all subtraction to addition plus the opposite sign. Pardon me, something caught my throat there. Change all subtraction to add the opposite. So what does that mean here? As I first go through it, I'm going to rewrite this entire problem and just change the subtraction to addition. Okay. I had to double check that I hadn't knocked the camera off center there. So as I copy this, I've got 5 times 3y minus 12. So instead of the minus, I'm going to write that as plus a negative 12. Then over here in this parentheses, I've got 14y minus 2. So instead of that minus 2, I'm going to write that as plus a negative 2. And in between here, I've got a minus. I've got this entire left side minus the right side. So instead of that minus, I'm going to write that as plus a negative. The negative is going to get applied to this parentheses. It's a negative times the whole thing that's in parentheses, the whole quantity. Okay. Now we talked about this earlier, and one way you can think of that is a negative 1 times that quantity. It's times the 14y plus the negative 2. Let's rewrite that whole thing again. 5 times 3y plus a negative 12 is really a plus, sorry about that, plus a negative 1 times that whole quantity here. We changed the minus to plus a negative. That's really being multiplied by a negative 1. And that's what we're going to do here. We're going to distribute. Now that's not the only way to think of it. I'll talk it through a couple other ways after we finish the math here. So hang with me if this is not feeling natural to you. Okay, let's go ahead and distribute. You're going to get 5 times the 3y plus 5 times the negative 12. And then you're also going to get the plus right here, that plus in between these two distributions that are happening here. And then you're going to get negative 1 times 14y plus negative 1 times negative 2. So it's negative 1 times 14y plus the negative 1 times the negative 2. And let's see what all those pieces equal. 5 times 3y, again, if you need to rearrange it either in your head or on paper till you're convinced that this is 15y. The 5 is not distributed. There's no adding here. It's just 5 times 3 times y. And so that is 15y. And then 5 times a negative 12, we've got a positive times a negative. The positive is not out here. This is the adding sign. The positive is what we don't see here. So write it in if it makes more sense to you. Positive times a negative is a negative, so this becomes plus a negative 60. 5 times 12 is 60. Then we still have this plus that keeps coming down, and then we do the negative 1 times the positive 14y. So this is still plus a negative 14y. 1 times 14 is 14. Negative times positive is negative. So it's a negative 14y. And then finally we've got plus a negative 1 times a negative 2. Negative times negative is positive. 1 times 2 is 2, so this is a positive 2. We've removed all parentheses. We're now looking to combine like terms. I'm a little short on space here, so I'm going to start using what I do as a technique for myself. Instead of physically moving everything around on the page using the commutative and associative properties of addition, I know that since I have all pluses here, I'm free to regroup and to commute and to pull anything that I want to go ahead and add first. And so for me, I just need to make sure I take the signs with. So for me, I go through first and look for matching variables. I've got a 15y and I've got a negative 14y. And I just give myself a little colorful visual symbol that those two are a match. So 15y plus a negative 14y is going to be a positive 1y. And everything is plus here, so I know I'm just going to be adding whatever my next item is. Okay. In this case, I'm bringing together the constants. So I'm just going to highlight those for myself by circling them. Just a little different symbol to know that those are the ones I'm combining here. Negative 60 plus a positive 2, signs are different, so I subtract. 60 minus 2 is 58. Keep the sign of the bigger number here. I've got 1y plus a negative 58. You can write that as just plain old y. Again, we want to save our ink, our paper, our time, chiseling, whatever it is there. That helps you get, I don't need to say 1y, I can just say y. And then plus a negative 58, or if you were to write that as y minus 58. Either of those would be fine. Also, you could have switched that around and done negative 58 plus y. As long as the 58 is the one with the negative attached to it, you are fine on that. Now, I promised you could think about this a different way, okay? My best suggestion to you is that you change all subtractions to make them adding the opposite. And when you see a negative in front of something, think of it as a negative 1 times the whole parentheses. And that's what we did here in red, is we just changed the negative out front of the parentheses to a minus 1 being multiplied. Here's another way to think about it. Up here at the beginning, when I've got minus this whole quantity, 14y minus 2, what I'm really saying by that is I'm taking away the 14y and I'm taking away the negative 2. Both items are getting taken away. Both items have to be subtracted. Well, subtracting 14y, that makes sense, right? Here it is right here. We ended up subtracting the 14y, which is adding a negative 14y. But when I subtract a negative 2, remember when I take away a negative, that turns out to be a positive thing. If I'm taking away a negative, if I'm taking away a debt that you owe, that turns out to be a positive end result. So when I take away a negative, that becomes a positive 2, like we came up with here. So this idea of thinking it in terms of subtraction, taking away both pieces, helps reinforce the rule that when you take away a negative, or you multiply a negative times a negative, which is what we're doing when we think of it in terms of negative 1 times that parentheses. Taking away a negative is the same as multiplying a negative times a negative, and that answer needs to be positive. Okay. So, here's a little reminder of that, what to do when you see a negative sign in front of the parentheses. The book describes it as you just change the sign of every term within the parentheses. Yet another way to think about it. I don't really care which way you do it. Your brain is going to have a way that really locks on to one way, and it makes the most sense to you, and you're going to get consistent right answers. Then that's the way you need to go. If it's different than the 3 ways we talked about here, the book way, think of it as subtracting both items inside the parentheses, or just straight distribution, multiplying by a negative 1. If you've got another 4th or even more ways to do this problem, please, I'd love to see in here about those. Okay, we'll see you at the bottom of the page for a couple more types of problems.